This is a video on the coordinate geometry of a straight line. In this video you will learn how to calculate the gradient between 2 points and also the equation of a straight line. Here we have 2 points, 5, 4 and -1, 2. We define the gradient as the vertical difference between the 2 points here divided by the horizontal difference between the 2 points here, and in this case we can see that is 2 divided by 6, which is a third. It's calculated by the difference in the y coordinates. We have 4 minus 2 divided by the difference in the x coordinates, 5 minus -1. And we call the gradient m. So that's 2 over 6 equals 1/3. If I change one of the points here, you see, that's 5, 5. Then the gradient becomes, that will be 3 divided by 6. That would be a half. Changing this point here to -2, 2, and the gradient would be 3 divided by 7, 3/7, and that's 5 minus 2 divided by 5 minus -2, which is 3/7. In general, if we label our points x1, y1 and x2, y2, then the gradient of AB, which we'll write m, equals the difference of the y coordinates, y2 minus y1, over the difference of the x coordinates, x2 minus x1. And actually it doesn't matter which way round we write the points, as we can see, as in the previous example, if we'd had 5, 4 and -1, 2, we can write 2 minus 4 over -1 minus 5 equals -2 over -6, which is also a third. You will need to know this formula for calculating the gradient between 2 points. Now let us consider a straight line. Here we have a straight line here, this red line, and if I take any 2 points on the line, we can see that we can see here the gradient is, we can see the gradient is 2. In this, for these 2 points, we have the vertical height, the difference in the y coordinates is 1, 2, 3, 4, 5, so 6 divided by 3, so that's 2. Move the point, that's 4 divided by 2, which is also 2, and with these 2 points here we have 12 divided by 6, which is also 2. So let's consider this line here. It has gradient 2, and we know, let's say we know it goes through the point 2, 1. So any other point on the line here, we know will move like this, because we have to have gradient 2. So we have this variable point, which we can call xy, and by joining up all of these possible points here, we create the line, always having gradient 2. Now we know that the gradient m is y2 minus y1 over x2 minus x1, so in this case our gradient is 2, and that equals, well, the 2 points are xy, the general point, and the fixed point 2, 1. So the y2 would be y, the y1 would be 1, the x2 would be just x, and the x1 would be 2. So we have this equation here. If I multiply both sides by x minus 2, I have 2x minus 2 equals y minus 1, and I have 2x minus 4 equals y minus 1, and moving everything onto the right, y minus 2x plus 3 equals 0, or y equals 2x minus 3, and this is the equation of that straight line. In this equation we see that the gradient is 2, and also we can see that the minus 3 is where the line crosses the y-axis here, and that's where x equals 0. We can see that if x is 0, y equals minus 3. In the general case, where we have a line with gradient m and a fixed known point x1, y1, and our general point here xy, we can say the gradient is m is the difference in the y coordinates, y minus y1, over the difference of the x coordinates, x minus x1. Multiplying, we get y minus y1 is m x minus x1, and this is the general equation of a straight line which you should remember. For example, find the equation of a straight line passing through passing through 1, 3 with gradient minus 3. We write the formula y minus y1 equals mx minus x1, and we substitute the values. Y minus y1 is 3 equals m, which is minus 3, x minus x1 is 1. The x and the y obviously are the variables for the equation, and then we simplify it. Y minus 3 is minus 3x plus 3, and y that equals minus 3x plus 6, and that's the equation of the line. Of course, a line can also be defined as passing through 2 points. We only have one line that passes through 2 points. So here we have the line passing through the point A14 here and B minus 32 here. So using the formula again, y minus y1 equals mx minus x1, we have x1, y1. x1, y1 could be either of these 2 points, it doesn't matter which, and m we find from the formula for the gradient. M is y2 minus y1 over x2 minus x1, and what we use one of these points as x1, y1 and the other as x2, y2, doesn't matter which. So let's say y2b is x1, y1, and a is x2, y2, and so we have y2 4 minus y1 2, 4 minus 2 over 1 minus minus 3, which is 2 over 4, which is a half. So the gradient is a half, and then substitute it in the formula. Y minus either of these 2 points, let's use a, so y1 is 4 equals m a half x minus x1 is 1, and if we simplify that, y minus 4 is a half x minus half, and adding 4 to both sides, y equals a half x plus 7 over 2. Now this is the equation of the line in y equals mx plus c format. The m is a gradient, which was in this case is a half, and the c here is the intercept with the y-axis there. So this would be 7 over 2 on the y-axis. However, a question will often ask you to write the equation of the line in the form ay plus bx plus c equals 0. This is another form of the general equation of the straight line, and in this format you must have a, b and c as integers or whole numbers. So to write the equation in this format, you would just multiply by a common denominator. Here we have y equals a half x plus 7 over 2. We would multiply everything by 2. 2y equals x plus 7. So all the coefficients are integers, and I would want to write all the terms on one side of the equation and write equals 0. So subtracting x and subtract 7 from both sides, and then you have the equation in the correct format. That is the end of the video on the equation of a straight line. Now return to Study Smart, where you will find an exercise to practice this.